Hello, I'm Vidya, your tutor. Let's learn continuity and differentiability together, step by step. This chapter builds the foundation of calculus, what it means for a function to be continuous and to be differentiable, along with the rules for finding derivatives. A function is continuous at a point a if the limit as x approaches a equals the function's value there. Intuitively, you can draw it through that point without lifting your pen. No breaks, jumps, or holes. The derivative is the limit of the difference quotient, the slope of the tangent line to the curve. A key fact: every differentiable function is continuous, though not every continuous function is differentiable. Memorize the standard derivatives. X to the n differentiates to n x to the n minus 1. Sine becomes cosine, e to the x stays e to the x, and the natural log differentiates to 1 over x. For combinations, the product rule, the quotient rule, and the all-important chain rule differentiate the outer function, keep the inner, then multiply by the derivative of the inner. Differentiate 3x plus 1, all to the fifth, using the chain rule. The outer gives 5 times the bracket to the fourth. The inner derivative is 3. Multiplying y prime is 15 times 3x plus 1 to the fourth. To recap, continuity means the limit equals the value. The derivative is the tangent slope. Differentiable functions are continuous, and the chain rule is the workhorse for composite functions. Well done! Great work! Keep learning with Vidya, and visit CBSETest.com for free lessons, worked examples, and practice tests.